Hello, let's work through solutions to the problems assigned out of section 6.3. First up, use the fact that trigonometric functions are periodic to find the exact value of the given expression without using a calculator. So specifically, the secant of 405 degrees is 1 over the cosine of 405 degrees, but cosine is periodic. Specifically, it has period 360 degrees. In radians, this would be 2 pi. So instead of calling this 405 degrees, observe that that's 360 degrees plus 45 degrees. That's 405 degrees right there. But cosine is periodic with period 360 degrees. So the cosine of 360 degrees plus something is the same thing as the cosine of that thing. You get to ignore going all the way around the circle. So instead of cosine of 360 plus 45, this is the same as the cosine of 45 degrees. And as we've seen several times by now, the cosine of 45 degrees is root 2 over 2, and this simplifies all the way down to just being root 2. So the secant of 405 degrees is exactly root 2. Similarly, sine also has period 2 pi. So 9 pi over 4 is 8 pi over 4 plus 1 pi over 4. In other words, it's just 2 pi plus pi over 4. But sine is also periodic with period 2 pi, so the sine of 2 pi plus theta is just the same as the sine of theta. You get to ignore going all the way around. So this here will be the same as the sine of pi over 4, which, as we've seen several times, is root 2 over 2. Cosine of 12 pi is the cosine of 2 pi plus 10 pi. I get to ignore going all the way around, so that's the same as the cosine of 10 pi. Well, that's 2 pi plus 8 pi. I get to ignore going around once, so this is the same as the cosine of 8 pi. But 8 pi is the same as 2 pi plus 6 pi. I get to ignore going around once, so this is the same as the cosine of 6 pi, which is going to be the same as the cosine of 2 pi plus 4 pi, but I get to ignore going around once, so that's the cosine of 4 pi, which is the same as the cosine of 2 pi plus 2 pi, but I get to ignore going around once, so that's the cosine of 2 pi, notably plus 0, and I get to ignore the 2 pi, so that's the cosine of 0, which is exactly 1. Alternately, you could have just looked at the beginning and said 12 pi. Well, that's 2 pi times 6. That's go all the way around the circle 6 times and end up exactly where you started, pointing at the point 1, 0. The x-coordinate is 1. Sine and cosine are given. Find the value of everything else. So we're given sine and cosine, which means all we have to find are tangent, secant, cosecant, and cotangent. Well, tangent is sine theta over cos theta. So that's negative 2 root 2 over 3 over 1/3. The 1/3s cancel, and this is just negative 2 root 2. Secant theta is 1 over cosine theta. 1 over 1/3, that's exactly 3. Cosecant is 1 over sine theta. So that's 1 over negative 2 root 2 over 3, which is 3 over negative 2 root 2. If I don't like having root 2 down in the denominator, I can call this negative 3 root 2 over 4. And cotangent theta, that's 1 over the tangent of theta. We've already found tan theta to be negative 2 root 2. And again, if I don't like having square roots down in the denominator, I can call this negative root 2 over 4. This is pretty straightforward. Since we were already given sine and cosine, finding everything else was immediate. Now, notice we're given sine, but we are not given anything else, except we are given the angle is in quadrant 1. Okay, and typically what we're going to start with is our trigonometric identity, sine squared theta plus cos squared theta equals 1. Since sine of theta is 4/5, when I square that, it's 16/25. If I subtract 16/25 from both sides, then I can take a square root. Sorry, not cos squared, now it will just be cos theta. Taking the square root of this, I'll get plus or minus 3/5. In quadrant 1, x is positive, so the cosine of this angle should be positive. So the cosine of theta is 3/5. If we were in a different quadrant, we might have had to take the negative answer, but in quadrant 1, cosine is positive because x-coordinates are positive. So sine of theta is 4/5, cosine of theta is 3/5. In other words, the y is 4/5 and the x is 3/5. And now I can just go forth and say this is sine theta over cos theta, which is 4/5 over 3/5, or 4/3. Once I have tangent, you can go ahead and say cotangent is just 1 over the tangent, so that's just going to be 3/4. Cosecant theta is 1 over the sine, so since sine theta was 4/5, 1 over that is 5/4. And secant theta is 1 over cosine, and since cosine theta was 3/5, this is 5/3. Getting cosine theta was all the work. Okay, in the last problem, since we had sine and cosine, everything was very quick to work through tangent, cotangent, secant, and cosecant. Here we were given sine but not cosine. The Pythagorean identity helped us find cosine up to a plus or minus sign, and this extra information about being in quadrant 1 is how we determined which one we were after. Okay. Now notice we have cosine is 2/3 and tangent is negative. Well, if I start with my Pythagorean identity, sine squared theta plus cos squared theta equals 1. Cosine theta is 2/3, so cos squared is 4/9. Subtract that. Sine squared theta equals 5/9. So the sine of theta is plus or minus √5 over 3. But how am I going to determine whether sine is positive or negative? Well, tangent of theta is sine theta over cos theta. Cos theta was given to us to be positive, and tan theta was given to us to be negative. So how can I have a negative number, tan theta, be sine theta over a positive number, cos theta? Sine theta had better be negative. If sine theta were positive, then on the right-hand side I'd have positive over positive, and that can't be a negative tangent, which we were told tangent is negative. So sine is negative, which means the sine of theta is negative √5 over 3. Now I have a sine value and a cosine value, so I can just go right ahead and say tan of theta is sine theta over cos theta. This is negative √5 over 3 over 2 over 3, or negative √5 over 2. Secant of theta is 1 over the cosine of theta. Since cosine theta is 2/3, this is just 3/2. Cosecant of theta is 1 over sine. Sine theta was minus √5 over 3, so this is minus 3 over √5. If you don't like radicals in the denominator, negative 3 √5 over 5. And finally, cotangent of theta, this is just 1 over the tangent of theta. Since tangent of theta was minus √5 over 2, this is minus 2 over √5. And again, if you don't like radicals in the denominator, negative 2 √5 over 5. Okay, we see a pattern here. Once you have sine and cosine, everything else is quite straightforward. If you have either sine or cosine, you can determine the other one up to a plus or minus sign, and then you rely on a little bit of extra information to determine which one is correct. So, similar, secant theta equals 6, cotan theta is negative. So our standard Pythagorean identity that we've been using was sine squared theta plus cos squared theta equals 1. Now, what I could do is I could say the following. Secant theta is 6 means 1 over the cosine of theta is 6. So 6 cosine theta equals 1 by cross multiplying, or cosine theta equals 1/6. Now I can use my standard Pythagorean identity, and I could say sine squared theta plus cos squared theta equals 1. Sine squared theta plus 1 over 36 equals 1, and now we're basically doing it like we've done the other problems. Okay, but I'm going to do this one slightly differently. Okay, let's look in the top right at that standard Pythagorean identity of sine squared theta plus cos squared theta equals 1. What I'm going to do is I'm going to divide both sides by cosine squared of theta. Okay, so if I divide this side by cosine squared of theta and I divide this side by cosine squared of theta, here I get sine squared theta over cos squared theta plus cos squared theta over cos squared theta by splitting that fraction apart, and here I have 1 over cos squared theta. So observe, this is sine theta over cos theta squared plus 1 equals 1 over cos theta squared. This is an alternate Pythagorean identity of, and I'm going to write it over on the left, tan squared theta, there's my sine theta over cos theta squared, plus 1 equals, and 1 over cosine theta is secant theta, but it is being squared. So this is an alternate Pythagorean identity that will more exactly use the fact that secant theta equals 6. 6 squared is 36. So what we have is tan squared theta plus 1 equals 36, or tan squared theta is equal to 35. This tells me that the tangent of theta is plus or minus root 35. Now how can I determine which it is? We were given that cotan of theta, I'm back on the right-hand side now, is negative. But cotan of theta is just 1 over the tan of theta. So if tangent were positive, cotan would be positive. If tangent is negative, cotan is negative, and vice versa. So since cotan is negative, tangent is negative. So the tangent of theta, I want to be negative root 35. Okay, so secant of theta is 6, tangent of theta is minus root 35. Now what we have to do is figure out everything else. And now we are going to use the fact that certain things are reciprocals of one another. So since the secant of theta is 6 and secant is 1 over cosine of theta, cosine of theta is 1 over 6. Okay. Since the tangent of theta is minus root 35, we can immediately say the cotan of theta is 1 over the tangent of theta, or 1 over minus root 35, and if we want to simplify those radicals, we get negative root 35 over 35. The only thing we're missing is cosecant and sine, and we have a couple of options. Okay, so one thing we can do, now that we know cosine, we can determine the value of sine. So one thing we could do is we could say sine squared theta plus cos squared theta equals 1. Cos squared theta is a sixth, so we have sine squared theta plus 1 over 36 equals 1. Sine squared theta equals 35 over 36. So sine theta is plus or minus root 35 over 6 when you take the square root. Then you'd say, well, how can I tell whether this is positive or negative? Cosine is positive, cotangent is negative, and cotangent is just cosine over sine. So since cosine is positive, sine had better be negative. That's one thing we could do. Okay. Another thing we can do is derive another alternate Pythagorean identity. So from our standard Pythagorean identity of sine squared theta plus cos squared theta equals 1, when I divided by cos squared, we got this one on the left, tan squared theta plus 1 equals secant squared theta. But what if I divide everything by sine squared theta? So if I split this up, I get sine squared theta over sine squared theta plus cos squared theta over sine squared theta, equals 1 over sine squared theta, which I can simplify as 1 plus cotan squared theta equals cosecant squared theta. And we've already determined cotangent theta to be negative root 35 over 35. Now if I square that, we get 1 over 35. So this gives me 36 over 35 equals cosecant squared theta, from which I can derive, and I'm just going to move back up to the top here, that cosecant of theta is plus or minus the square root of all this. So cosecant of theta is plus or minus 6 over root 35, or plus or minus 6 root 35 over 35. How am I going to determine whether I want positive or negative? Well, secant was positive, meaning cosine was positive. Tangent was negative, meaning cotangent was negative. Actually, it was the other way. Cotan was given to be negative, and we determined that tangent was negative. So since cotan and tangent are both negative, between sine and cosine, one is positive and one is negative. Since cosine was given to be positive, that means the sine function is negative, which means 1 over the sine function is also negative. So cosecant is negative. So cosecant theta is negative 6 root 35 over 35. And then finally, the sine of theta is 1 over the cosecant. Or negative 35 over 6 root 35. Simplifying that fraction back down gives me negative root 35 over 6. So we did this last problem in a few different ways. You never have to do a problem 8 different ways unless you're specifically told. I just wanted to show that there are many ways to get to the same answer in these problems by using various different trigonometric identities. Whichever way is most comfortable for you, go ahead and stick to that unless you are just practicing.